In this lesson, we will look at our final class of reversible inhibitors and also look at some general lessons regarding irreversible inhibitors. Our final classification for reversible inhibitors is uncompetitive. This type of inhibitor binds only the ES complex, never the free enzyme. The equilibrium associated with binding is shown here. Since it binds to the enzyme in the presence of substrate, it blocks the catalytic step and therefore lowers Vmax. Product can be made once the inhibitor is released, but the rate will be less than if the inhibitor were not present. As we examine the equilibrium expression, we might assume that an uncompetitive inhibitor does not influence substrate binding. In fact, it lowers the value of Km. Recall that a lower value of Km indicates a higher binding affinity. So in essence, the inhibitor helps the substrate bind. How can this be? Let's take a moment to review Le Chatelier's principle, that if stress is applied to a system at equilibrium, it will shift in such a way as to relieve the stress. In this case, the amount of ES complex is being lowered due to conversion to the EIS complex. The system compensates by generating more ES. This means that formation of ES is favored and Km decreases. Don't forget though, this inhibitor still lowers Vmax and is therefore negatively affecting enzyme activity. Let's now look at the effect on the Lineweaver-Burke equation. Since an uncompetitive inhibitor lowers Vmax, it will increase both the slope and y-intercept by the alpha factor, as shown in the equation here. However, it also decreases Km by the same amount. When we modify all of the terms appropriately, we see that the alpha factors in the numerator and denominator of the slope cancel, and our equation simplifies. We would predict, therefore, that the Lineweaver-Burke plots would produce parallel lines with increasing slopes. Just as we expected, the lines don't intersect at any point, but remain distinctly parallel. One final word on inhibition has to do with irreversible inhibitors. These inhibitors permanently alter enzyme activity in some way, thus lowering the effective concentration of the enzyme. Some of these bind the enzyme covalently and thereby render it inactive unless the modification is reversed. Suicide substrates are molecules that can bind at the enzyme active site, but they cannot be released. It's as if the enzyme tried to use the substrate, but then can't complete the reaction. It cannot move through the reaction sequence, but then it can't reverse it either. It just becomes permanently stuck in place. These are sometimes referred to as Trojan horse substrates, since they sneak into the active site and then cause damage. An example of a naturally occurring suicide substrate is the antibiotic penicillin. It may not be apparent at this point, but the study of enzyme kinetics can greatly aid the understanding of how metabolic and other systems function, and that allows us to modify enzyme behavior in order to thwart potential disease states.